The Bondi Geological Heritage Site was declared a protected area by the Department of Environment and Planning in 1985. It is located on the eastern boundary of the North Bondi Golf Course, named Williams Park. So by all means explore and take pictures of the rocks, but please leave the area as you find it. I first visited this area with a group of Sydney University students in 1965. Since then, the cliff has eroded dramatically and the cliff edge is most dangerous. The basalt volcanic neck is weathered to soft, slippery brown and white clays. Any attempt to descend to that material will result in a painful death. The sandstones are undermined by soft shale layers at sea level. The minerals that cement them have leached out by weathering, and they are cut by ancient cracks that geologists call joints. Do not walk to the edge or visit the central stack. All along our coastal and Blue Mountains cliff lines there is a worrying death toll of young people who disobey that advice. Enjoy taking your pictures, as I did, from a distance. The Reverend William Brandwhite Clark was Australia's first geologist with a double degree from Cambridge and a Fellow of the London Geological Society. Arriving penniless in 1839, he ran several Anglican schools and churches, was curator of the Australian Museum, and mapped much of Australia on horseback. On this 1880 map, he has a number of key sedimentary rock formations, with the youngest at the top. He also shows granite intrusions and volcanics. This more modern map shows Bondi and the cliffs to the north. The green is Hawkesbury sandstone, and the purple the younger Wainemata Group shales. The brown is mangrove muds, and the yellow is sand dunes, which sit very high up the cliff, as well as down on the beaches. This clip looks south from North Head to the sandstone cliffs that guard the eastern suburbs, including Bondi from the sea. I am very high up, yet there are thick sand dunes behind me. Those dunes piled up during the last glacial stage 25,000 years ago, when the harbour was a narrow river, the sea 120 metres lower, the coast 6 kilometres east, and the wind howling from the south. German polar explorer Alfred Wegener published his theory of drifting continents starting in 1912 and began collecting evidence based on rocks and fossils that South America and Africa had been joined together. The Americans ridiculed him before his death in 1931. Samuel Warren Carey was a Depression kid from Campbelltown who went to Canterbury High School and Sydney University, where he gained a Master in Geology. From 1934 to 1942, he mapped the wilder parts of New Guinea for oil companies with a team of 30 natives. When war started, he and his brother were Z's Special Unit Commando lieutenants. The brother was captured, tortured and beheaded at the end of the war. After the war, Carey became Professor of Geology at Tasmania University, where he championed and developed plate tectonics theory. Plate tectonics was accepted as the present model in the 1960s, explaining the formation of new crust at mid-oceanic rises and the increasing ages of oceanic crust out from the spreading centres. What can be debated is the causes of the big convection currents in the mantle. The supercontinent Pangaea formed 300 million years ago at the start of the Permian period by the coming together of bits of continental crust. Australia is down near the South Pole, east of Antarctica. The breakup of Pangaea began with the formation of rift valleys in the Jurassic period 150 million years ago. These widened to seas and oceans. Of interest to us is the opening of the Tasman Sea between 85 and 55 million years ago, and the separation of Antarctica from Australia starting 80 million years ago. The Sydney Sedimentary Basin is a huge column of up to 5 kilometres of Permian and Triassic rock layers in the shape of a chopped-off saucer. It is wedged between older Paleozoic fold belts to the west and east that eroded to produce the basin sediments. The basin is related to the Bowen Basin, shown in blue to the north, as well as 3 other basins shown in yellow. This sketch, with a greatly magnified vertical scale, shows the Sydney Basin in cross-section from west to east. The basement rocks of the Lachlan Fold Belt are in pale mauve and red. Bondi's Hawkesbury Sandstone is the second top layer in yellow. The Prospect Volcanic Neck in purple punches up into Waitemata Shales near the start of the Jurassic geological period 210 million years ago. It is believed to be the same age as over 30 dikes and diatremes, including those at Bondi. This snapshot at the start of the Permian shows a subduction zone crunching the New England Fold Belt, allowing the sea to enter. 60 million years later, at the end of the Permian, both fold belts have uplifted, and we have both saltwater sediments and coal measures forming in swampy areas. 20 million years later, in the Triassic, the sea is retreating and the rocks to the west uplifted. A 260-metre thick column of sandstone rocks at Bondi form in constantly changing channels of a major river system flowing mostly from the south. We will start at the south side of the golf course and work north. Looking south, we see the cliffs of Benbuckler, which form part of the Hawkesbury Sandstone column. It is a very pure, even-grained quartz sandstone with some iron oxide staining and occasional quartz pebbles. Fossil lungfish and big insects have been found at Brookvale Quarry. Occasional fossils of the Triassic seed fern Dicroidium are found in some shell bands. These and fossils found in the layers above and below this formation indicate an age of 240 million years. The sandstone shows current bedding formed when underwater sand dunes migrate forward. What do you think Professor Gordon Packham has noticed about this outcrop? Could it have been something to do with the fact that the sandstone formed near the South Pole? We move north to a place where 2 big vertical dikes intersect. They formed when basalt magma rose through weaknesses in the sandstone in the Jurassic period, forming 2 walls of black rock. This is what a young dike looks like at Kiama. Basalt minerals quickly weather to clays and iron ore when exposed to air and water, and what we get are 2 big, scary chasms. The first Bondi sewer outfall was built in 1889 with a tall brick chimney, and it polluted the local beaches. The more modern deep-water outfall plant was opened in 1990 and is at the top of the golf course. Its tunnel intersected one dike below sea level. The basalt was still present, as there was less air to weather it. The Suir releases its screened waste in 60 metres of water 2 to 4 kilometres offshore. We travel further north to the remains of an old quarry containing prismatic sandstone that was valued as a hard building stone. Columnar jointing commonly forms in big basalt lava flows where the new rock shrinks as it cools. It is rarer in sedimentary rocks, but occurs at a number of locations around Sydney. The western side of the quarry shows current bedding and a scour and fill structure in the sandstone. As we move further east, closer to the intrusion, we see prominent current bedding, increasing hardness, and the appearance of columnar jointing. The heat of the intrusion caused the sandstone to be changed or metamorphosed into the metamorphic rock quartzite. The quartz grains have combined by recrystallisation into harder, denser forms. The rock shrank and cracked as it cooled. Basalt columns typically have 6 sides. How many sides can you see? Now we are looking for the intrusion that was first described by Brennwhite Clark in 1866. We start at the stack and pan left. All this white and brown material is part of the intrusion except the squarish sandstone islands in the distance. Now we look down the intrusion to the basalt islands which are part of it. The original basalt would have been a black rock containing olivine, augite and plagioclase felspar. On the dangerous cliff face, it is weathered to brown iron ore and white clay. Heroic polar explorer Edgeworth David wrote at our biggest state funeral in our history when he died in 1934. In 1886, he noticed shuttered shale and sandstone fragments within the basalt. The eruption which injected the basalt and cooked the sandstone was an explosive one, probably involving exploding steam and shooting material out of a crater. Nearby dinosaurs would have bolted. This is what we think the intrusion looked like. Hot steam blew out a funnel-shaped crater. Bits of sandstone and rock fell back into the crater and met the rising magma. It is called a marred diatreme, and the top half of it has eroded away. Finally, we walk to the top of the golf course where we find Aboriginal carvings that date sometime in the last 40,000 years. This was the place where elders educated their youngsters using dance, music and ritual chanting. They were thorough teachers, insisting on accuracy in memorising their tribal history.